Hi guys, today we're going to continue talking about polynomials. To be more specific, we are going to focus on the remainder theorem, the factor theorem, and then we'll wrap up this video by using both the remainder and factor theorem to find the zeros algebraically for a given polynomial. Okay, so I'm going to read to you and then I'm going to try to break it down with these fun problems. So let's do this. So the remainder theorem, what does that say? The remainder theorem says this: if I have a polynomial and I divide it by a binomial of the form x minus r. Does that look familiar from our synthetic division unit? So the remainder theorem says this: if we have a polynomial and we divide it by a binomial of the form x minus r, then the remainder is given by p of r. Okay. So again, I'm just going to read to you and then I'll try to break it down with our fun problems. Okay, factor theorem. So the factor theorem says this: if I have a polynomial, x minus r is a factor if and only if p of r equals 0, whatever that means. Okay, cool. So again, let me try to break down these to you across our fun problems. Okay, so first fun problem reads: use the factor theorem to determine whether the given binomial is a factor of the polynomial p of x. Okay, so let me just go ahead and start by writing the polynomial. So we have p of x equals x squared minus 9. And I want to know, is x minus 3 a factor? Okay. Alright, so how does this factor theorem work? Okay, so it says the polynomial x minus r is a factor of the polynomial p of x if and only if p of r equals 0. Okay, I didn't get it either. Okay, so let me write some words. So if, okay, we don't really know. Okay, pretend you can read that. Okay, the question says is x minus 3 a factor of p of x of the polynomial? So if x minus 3 is a factor, what has to hold true? If x minus 3 is a factor, then what would be the corresponding 0? Okay, I can't do that in my head, so I'm going to show some work. So we're going to take x minus 3 and set that equal to 0. So if x minus 3 a factor, then when we add 3 to both sides, that will give us 3. Okay, so if x minus 3 is a factor, then 3 should be a 0. Okay, so if 3 is really a 0, then when we evaluate the polynomial at 3, the function value should be 0. Okay, we're going to knock it out and then we'll go back to me trying to explain this. Okay, so again, if x minus 3 is a factor, then 3 should be a 0. Okay, 3 should be a 0 of the polynomial. And if 3 is a 0, then when we evaluate the polynomial at 3, the function value should be 0. So let's do this. So let me just write down verify, see, or check. I'll just put verify. Verify or see, because I don't know which word I like best. Verify or see if when we evaluate the polynomial at 3, that gives us 0. Again, why does it have to be 0? Because it comes from math. If x minus 3 is a factor, then 3 should be a 0. If 3 is a 0 of the polynomial, then when we evaluate the polynomial at 3, the function value should be 0. So let's do this. So let's plug in the 3 for the let's go ahead and substitute a 3 for the input. So I'm going to start off by writing a polynomial. You know me, I try to minimize the mental math because who likes to do mental math? Not I. At the time it seems great, but then when you use your notes for studying, how often do you say, oh, how did I get this, how do I get that? But if you speak to yourself, write yourself little love notes, then you don't have the situation. Okay, let's do this. So we want to find p of 3, so we want to evaluate the function at 3. So we're going to substitute a 3 for the input x. So wherever we have an x, let's swap it out for 3. Okay, so we have x, which we're substituting for 3. What are we doing to the x? We're squaring it, minus 9, and I think that gives us 0. Okay, square of 3 is 9, and difference of 9 and itself will give us 0. Okay, let me just bring this down. So the question was, is x minus 3 a factor of the polynomial? And we had said what has to hold true. Okay, if x minus 3 is a factor, then 3 should be a 0. We do the math to see if it really is a 0, and then in this case it does. So to answer the question, is it a factor? Yes. Okay, now let me try to explain it. Okay, so let's go ahead and apply what we did with this. Okay, so it says the factor theorem states that x minus r is a factor of p of x if and only if p of r equals 0. Okay, so if I try to break that down, if x minus r is a factor, what would that mean? What would have to be a 0? Okay, so again, you know me and my mental math is not so good. Okay, so if x minus r is a factor, then x equals r should be a 0. And if r is a 0, then when we evaluate the function at whatever we think the 0 is, the value of the function should be 0. Okay, maybe I didn't make sense, but hopefully I did. Okay, let's go ahead and knock out problem B, and that will be the end of this round right here. Okay, problem B. Is x plus I a factor of p of x equals, you can read. So the question is x plus I a factor of the polynomial? We're going to do the same speech. Okay, so we're going to start off by writing out the polynomial. We have p of x equals x to the 8th plus 1. I'm trying to like paraphrase it. And I want to know, is x plus I a factor? Okay, to make that call, we're going to use the factor theorem, and we're going to follow the same speech. So if x plus I is a factor of the polynomial, what would have to hold true? So if x plus I is a factor, then what would have to be the corresponding 0? Okay, so I know you can do it in your head, but you know me, I'm showing my work. What would have to be the corresponding 0? So let's go ahead, set that equal to 0, and then we'll solve for x. So if x plus I is a factor of the polynomial, then negative I should be a 0. Okay, I forgot the word a. Okay, should be a 0 of the function. Okay, so if negative I is indeed a 0 of the function, then when we evaluate the function at negative I, the function value should be 0. Okay, I didn't box my answer. Okay, so I'm gonna put verify or see if when we evaluate the function at negative I, see if that gives us 0. Okay, you didn't see that. Okay, all right, cool. So let's go ahead, write down the polynomial. So we have p of x is equal to x to the 8th plus 1, and let's see if negative I is indeed a 0 of the polynomial. So that will give us x. We're going to substitute a negative I for the input of x. So that will be negative I. What's going on with that negative I? It is being raised to the 8th power. And then we're going to add 1 to it. I would like to show off my amazing math skills and evaluate this mentally. But I'm too tired. So we're just going to punch it in. Okay, no one's going to know. Okay, so we have, oh, that's from a previous problem that we knocked out. Okay. Go ahead and clear this. So we have negative I, open parenthesis. Where is I? Okay, I wish I had my fake calculator. Okay, because this the sun is in my way. Okay, so the I button, where is that? So it's where the decimal point is. I want to point out that I is not the main key, it's the behind key. So if you want to use the behind key, you have to hit second. So you're going to do second I. Okay, so second I. Cool. Oh, but it wasn't I, huh? It was negative I. My mistake. Okay. Negative sign, not to be confused with a subtraction sign, please. So we have negative I. So second I, we have negative I. Close the grouping symbol, raise that to the 8th power, and the calculator will tell you what that evaluates to. So that will give us 1 plus 1. So the moral of the story is this: when we evaluate the function at negative I, that does not equal 0. Okay, so this is a lie. Okay, negative I is not a 0 of the function. So to answer the question, is x plus I a factor of the polynomial? The answer is no. Why not? Because what should be the corresponding 0 is not really a 0. Cool. Alright, so let's go ahead and wrap up this page with 2 more fun problems, namely A and B. So we have another polynomial, a degree 4 polynomial, and then we are asked to find p of negative 2 directly. Okay, I'm not going to dig too deep into it, so I'm just going to put find p of negative 2. Now, whether or not it says directly, If it says p of negative 2, I know how I'm going to handle it. So the question is saying, I want to know what is the value of this function when the input is negative 2. And that's something that we knocked out at the beginning of the course. So let's go ahead and start off by writing p of x. So we have p of x equals 3 times x to the 4th minus 16x squared minus 3x plus 7. And we want to find p of negative 2. So what we're going to do, we are going to substitute a negative 2 for the input of x. So wherever we have an x, we're going to swap it out for negative 2. This is something that I started doing recently, and I wish I had done it before, because it kind of highlights like where am I going to substitute these numbers. But if you don't need it, then I don't need it. So that will leave us with 3 times x, which is negative 2. What are we doing to the x? We're raising it to the 4th power, and then minus 16 times another x. Again, we're replacing it with negative 2. What are we doing to the x? We're squaring it. Minus 3 times another x, or negative 2, plus 7. Cool. So I could show off my amazing arithmetic skills, but we have no time for that. But what I want to point out is this. At this point, it's just a straight arithmetic, okay? That there's no algebra involved. So there's no need for you to show me the computation. So if you have access to a calculator, go ahead, punch it in. And if you don't, then freehand it, okay? So by some miracle, that whole expression simplifies to negative 3, okay? So you can either just box the answer, or you can tell yourself what equals negative 3 and be like, oh, look, the polynomial. When we value at negative 2, that gives us negative 3. So full credit for either one. Now, for some weird reason, we are asked to do this problem again, but we are not given the liberty to find it however we want. We have to find p of negative 2 by using the remainder theorem and synthetic division. Okay, remainder theorem. Who knows what that is? Okay, so let me go ahead and try to project this. We'll see how this goes. So the remainder theorem says this. If I have a polynomial and divide it by x minus r, then the remainder is given by p of r. Okay, so I guess we have to do some division. Okay, so hold on. Okay, this is not good. Okay, let me go ahead and write down the polynomial again. So we have p of x is equal to 3 times x to the 4th minus 16x squared minus 3x plus 7, and we are asked to find p of negative 2, not by using the technique of our choice. Okay, we have to use the remainder theorem. So in this case, we are gonna have to take the polynomial and divide it by x minus r. Okay, we have to divide it by some binomial. Okay, so in this case, where am I? So in this case, we're gonna say that x equals negative 2. Okay, what are we gonna divide by? We're not gonna divide by x equals negative 2. Okay, so we're gonna go ahead and set this equal to 0. Let's go ahead, add 2 to both sides, and that will give us x plus 2 equals 0. Okay, so in order for us to find p of negative 2, not however we want, but in order for us to find p of negative 2 by using the remainder theorem and synthetic division, we're going to have to divide the polynomial by x plus 2. So let me just go ahead and put divide. I'm going to have to take the polynomial and divide it by x plus 2. Cool. Now, should we use long division or synthetic division? Synthetic division, because the problem said so. Okay, but now the question is this really prepped up for synthetic division? So for synthetic division, we can use synthetic division if we're dividing by a binomial of the form x minus a number. So again, our book uses the variable r. We don't quite have x minus a number, okay, but we're gonna force it. We're gonna write x plus 2 as x minus negative 2. So we have it undercover x plus 2. So to answer the question, are we now dividing by a binomial of the form x minus a number? We are, okay? And in this case, the number that follows the subtraction sign is negative 2. So r equals negative 2. Sorry guys, this is what happens when you run out of space. remind me to invest in another sheet of paper. Okay, so let's do this. Okay, so let's prep this up for synthetic division. Outside the division box, we're gonna put the value of r. Okay, value of r is -2, and then for the inside the division box, we're gonna put the coefficients of the polynomial. The degree is 4, so we should have an x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, constant. So yeah, more squeezing. Yeah, this is not going down how I want it. Sorry guys. Okay, so let's go ahead extend this division box. Let's go ahead separate the quotient. Let me zoom this in. Let's go ahead separate the quotient from the remainder. Okay, the coefficients. The coefficient of the x to the 4th is 3. Coefficient of the x to the 3rd, nothing. Okay, we don't have an x to the 3rd, so we're gonna need a 0 placeholder. Coefficient of x to the 2nd, -16. Coefficient of x to the 1st, -3. Coefficient of x to the 0, which is code for constant, is 7. Okay, so we have prepped this up for synthetic division. Let's do this. Okay, so in this case, to divide synthetically, we'll drop down the 3, and then we follow the multiplication addition process. So let me go ahead and put my times, and we're gonna do this. Product of 3 and -2 is equals -6. When we keep our cool, sum of 0 and -6 will give us -6. Okay, I'm not gonna switch pens anymore. It's getting really annoying. Product of -6 and -2 will give us 12. We keep our cool, and that sum will give us -4. Product of -4 and -2 is 8, and that sum will give us 5. Okay, almost done guys. Product of 5 and -2 will give us -10, and then that sum will give us -3. Okay, so we are done. Okay, so the remainder theorem, I don't want to move the paper anymore, but what does the remainder theorem say? Okay, so the remainder theorem says this: if we have some polynomial and we divide it by x minus r, then the remainder is given by p of r. Okay, so we wanted to find p of r by using the remainder theorem and synthetic division. So p of -2 is given by the remainder. Okay, so since the remainder is given by -3, when we took the polynomial and divided by x plus 2, that gives us a remainder of -3, and that will be p of -2. Why do we have to find p of -2 like this? It was just so much easier to do it directly. I know, but we have to follow the book directions. So I always find it directly. I only do it like this if the directions say so, and if they don't, then just do it directly. Cool. Now I would like to stop the video here, but if I stop it, I think it's gonna be a disservice to you. Okay, so we're gonna go ahead get to like the main course of this video. Okay, we are gonna find the zeros of a polynomial. We're gonna find the zeros algebraically. Okay, so let me go ahead, bring my paper. Cool. All right, so this problem, you're totally gonna see this on the assessment. Okay, so it says use synthetic division to show that x equals -2 is a zero of p of x equals, you can read. Okay, so use synthetic division to show that x equals -2 is a zero of the polynomial p of x, and then find all other zeros algebraically. Okay, let's do this. So I'm gonna speak to myself. So if okay, if -2 is a zero, okay, is a zero of the polynomial, what has to hold true? What will be the corresponding factor? So let me bust out a thinking area. So we have x equals -2, we add 2 to both sides, and that will give us x plus 2. Okay, so let me go ahead, close off my thinking area. So if -2 is a zero of p of x, or the polynomial, then this means that x plus 2 would have to be a factor. Then x plus 2 should be a factor of p of x. For this problem, we're going to write all the love notes, and for the second and last problem, we're going to go straight to the punchline. Okay, so to show that x plus 2 is a factor, we're going to divide, kind of like, I'm going to digress a little bit. So let's just say if I said, hey, is 3 a factor of 12? So let's just say your preschool friend says, hey, is 3 a factor of 12? And you say, yeah. And then your preschool friend says, why? You can explain it however you want, but I'm going to explain it using what we're doing here. Well, if 3 is a factor of 12, when we divide, the remainder should be 0. Okay, so when we divide, 3 goes into 12 4 times with the remainder 0. Okay, I know you can just say 3 times 4 is 12. Okay, but I wanted to do it like this. Okay, so 3 is a factor of 12 because when we divide, the remainder is 0. Okay, so using that strategy, if x plus 2 is a factor of the polynomial, when we divide, the remainder should be 0. So let's go ahead, divide, and verify that the remainder is 0. So, divide the polynomial by, where am I, x plus 2, and confirm. How do you spell confirm? Oh, with the M. I already put an R. Sorry. Divide the polynomial by x plus 2 and confirm that the remainder is 0. Okay, I'm going to pretend you can read that. Okay, so let's go ahead and prep this up for synthetic division. Let's do our division box. Outside the division box, we're going to put the value of r. So again, synthetic division is a shorthand when we are dividing by a binomial of the form x minus a number. Our book says r. X minus a number. So in this case, we don't really have x minus a number, but we're going to force it really quick. We're going to write it as x minus negative 2. So now the question is, what is the value of r? The value of r is always the number that follows the subtraction side. So in this case, the value of r is negative 2. So let's do this. So again, the top row, you know how that works. For the top row, we're going to put the coefficients of the variable terms. So the degree is 3, so we need to have a degree 3, 2, 1, 0. Blast off. So let's highlight the degrees. So we have an x to the third, x to the second, x to the first, constant, which is our degree 0 term. Okay, so let's do this. So the coefficient of the x to the third term is 1. For the x to the second, it's 2. For the x to the first, is negative 9. And the constant term, or the degree 0 term, is negative 18. While we're at it, let's separate the quotient from the remainder. Okay, so let's go ahead, begin to divide. Let's go ahead, drop down the first number, 1. And then we're going to multiply, add, until we can't anymore. Product of 1 and negative 2 will give us negative 2. And that sum will give us 0. Next product. Product of 0 and negative 2 will give us 0. And that sum will give us negative 9. Next product. Product of negative 9 and negative 2 will give us 18. And the sum is 0. Okay, let's write down what the quotient would be. Since the degree is 3 in the dividend, the degree of our quotient should be 1 under, or 2. So this will be x to the second, x to the first, constant, and then the remainder. Okay, what did we say has to hold true? We had said that if negative 2 is a 0 of the polynomial, then x plus 2 should be a factor. So when we take the polynomial and divide by x plus 2, the remainder should be 0. Is the remainder 0? Yeah, so I'm jumping for joy. That's my smiling face. Pretend you can see it. Alright, so let's go ahead, begin to write the polynomial in factored form. So we have p of x, and we just divided by x plus 2. And we're going to multiply it by the quotient, which is given by 1x squared plus 0x minus 9. Okay, but let's clean that up. That's a quotient is given by x squared. There's no need to put plus 0x. We're going to put minus 9. Okay, so we had begun to factor. Cool. Now we have to find the rest of the zeros. They gave us 1. We have to find the rest. The degree is 3, so we're expected to have 3 zeros. We may have less, okay, but yeah, okay. So let's go ahead and do this. So when we set this equal to 0, the first factor will lead to a 0 of -2, like the problem said. We just want to find the additional zeros. So if you want to know what makes it a 0, let's go ahead and set that factor equal to 0. So we have x squared minus 9, and I'm out of space. Okay. So let me just put a little love note here because I don't want you thinking that I ignored it. Okay. This one I skipped it because we already knew that it was a 0 from the problem. Okay. So the additional zeros is x squared minus 9 equals 0, and then you solve this however you like. You can solve it by factoring or any other technique. We're going to solve by using the square root method. So let's go ahead and isolate the squared part so we can then square root both sides. When we keep our cool, after we square root both sides, you can either write down absolute value of x, or you can just put a plus or minus on the right side and you're good. On the left side, the square and the square root undo each other, and that will leave you with x equals plus or minus whatever the square root of 9 simplifies to, which in this case is 3. So now I'm at a crossroads. How should I submit my answers? So it says use synthetic division to show that x equals -2 is a 0 of the polynomial. So we did it. Okay, the remainder is 0, so we showed it. And then find all other zeros algebraically. Okay, so technically we just have to submit 3 and -3. But if you want to put the rest of the, if you want to put this one too, I'm okay. So additional zeros are gonna be 3 and -3. If you're not gonna sleep tonight because you didn't include -2, go ahead, put it. I don't really care. All right, so one more problem because we can't be pros after one problem, but I'm not gonna put all the words because that takes us forever. Okay, so problem B reads, use synthetic division to show that x equals -1 is a 0 of p of x equals. So use synthetic division to show that -1 is a 0 of this polynomial, and then find all other zeros algebraically. So we're gonna write down we're pretty much gonna do the same thing, but I'm not gonna write all the words. Okay, so what do we have? So -1 should be a 0. If -1 is a 0, what should be the corresponding factor? You can do it in your head or you can show the work. Okay, if -1 is a 0, then x plus 1 should be a factor. So we're going to take the polynomial divided by x plus 1 and then confirm that the remainder is 0. So let's do this. So we are going to use synthetic division to divide. We're not going to use long division. Synthetic division is a shorthand when we're dividing by a binomial of the form x minus a number. If we don't have x minus a number, we'll force it. Okay, so we're gonna force x plus 1 as x minus -1, and then with confidence I can be like, are we really dividing by a binomial of the form x minus a number? And in this case we are. Okay, so that will give us that r is -1, or your book may say a. Okay, as a student I saw a. Okay, this book that we're using says r. Okay, so let's do this. Let's prep this up for synthetic division. Outside the division box, we're going to write down the value of r. The value of r is -1. In the top row, we're going to put down the coefficients. The degree is 3, so we should have an x to the third, second, first constant. So let's do this. So we have x to the third, x to the second, x to the first, constant. Okay, let's go ahead and write down the coefficients. Coefficients of the x to the third is 1. Coefficient of the x to the second is -1. Coefficient of the x term is 8. And coefficient of the constant term is 10. Okay, well, it's just the constant term, but I kept the same wording. Let's separate the quotient from the remainder. So we just pretty much we separate the last column. Okay, so let's go ahead and begin to divide synthetically. So the procedure says drop the first number and then multiply and add until you can't anymore. Okay, when we drop the first number, that will give us 1, and let's begin the multiplication addition process. Okay, let's do this. product of 1 and -1 will give us -1. Take your time. The question that I get asked from students, do we have to put a plus sign? No. Do we have to put the time sign? No. But I love writing. Love those to myself, so that way I can see where is it that the -2 came from without losing time to be like, how do we get that? Okay, so let's keep multiplying and adding until we can't anymore. Next product, -2 times -1 will give us 2, and then that sum will give us 10. Okay, next product, 10 times -1 is -10, and then that sum gives us 0. So let me go ahead, highlight the quotient and the remainder. So we divided into a degree 3 polynomial, so the degree of our quotient needs to be 1 under. It's always 1 under, not 2 under. Okay, so we should have x is the second, x is the first, constant, followed by the remainder. Now, what did we say? We had said that if -1 is a 0, then x plus 1 should be a factor. And if x plus 1 is a factor, when we divide by x plus 1, the remainder should be 0. We have shown that -1 is a 0. Cool. So now we have to find the rest of the zeros algebraically. Okay, so let's go ahead, begin to write down the polynomial in a factored form. So what did we do? We took the polynomial and we divided by x plus 1, and then that we're gonna multiply it by the quotient, which is 1x squared minus 2x plus 10. So we have 1x squared, or just x squared, minus 2x plus 10. Fantastic. So the degree is 3, so we're expected to have 3 zeros. When the first factor is going to lead to a 0 of -1, but that one was already given. This is why the problem says find the rest algebraically. You want to find the rest of the zeros? Then let's go ahead, take that second factor and set that equal to 0. Okay, so in this case, we try to solve however we want. You could solve by factoring, but no, this one is not factorable. Okay, it's not factorable, so you can solve it by completing the square or using a quadratic formula. Students tend to favor quadratic formula, so I'm gonna give the people what they want. So let's go ahead, bust out the formula. So we have x equals sorry so we have x equals opposite b. I was gonna sing to you, but I got nervous. Okay, what is it? What does it say? Stage fright. Yeah. So we have x equals opposite b plus or minus the square root of b squared minus 4ac, and that's all over 2a. Okay, please make sure you extend the fraction bar. On a lot of papers, I see the students just put the fraction bar underneath the radical. Okay, so for my peace of mind, I'm gonna highlight the values for a, b, and c. So leading coefficient, that's our a. Coefficient of the middle term is a -2, that's our b. Constant term is 10, that's our c. We nailed the formula. We have A, B, C identified. We're on track to get full credit, so let's do this. Okay, so we have x equals opposite b. Value of b is -2. So when we simplify that, that should give us +2. Fantastic. Then we're gonna add or subtract the square root of b squared. Value of b is -2, and we have to square it. Please make sure you wrap up your negative base with parentheses. This simplifies to +4. Without parentheses is -4. And quadratic formula is neat, okay, but it's heavy computation. So if you miss something, then it's gonna get ugly really quick. Okay, let's keep going forward. So minus 4 times a, value of a is 1. I always have my finger on once on the ABC, and then I write with the other. Minus 4ac, so value of c is 10, and that's all over 2a. Okay, fantastic. Oh, I didn't write down what a is, sorry. 2 times a is 1. Remember, sleep is important. That's my PSA for the day. Okay, so let's go ahead, begin to simplify this. So we have x equals opposite of -2 is +2, and then we're going to add or subtract whatever the radicand simplifies to. We could freehand this, but I'm going to punch it in, and when we do, the square of -2 minus 4 times 1 times 10, according to my calculator, which I'm not projecting, is a -36. and that's all over 2 times 1 over 2. So that is our answer. We just have to take our time and simplify that. So where am I? Where do I have more space? I'll do it right here. Okay, so we have x equals 2 plus or minus whatever the square root of negative 36 simplifies to. I know you can do it in your head, but I can't, so I'm going to show my work. Okay, so if I show my work, the first thing we want to do is make the radicand positive, and to do that we're going to replace the square root of negative 1 with the imaginary unit I. Okay, so that will leave us with I times the square root of the leftover radical. Okay, last time I checked, the square root of 36 is 6. Cool. And that will leave us with 6i. So let me go ahead and close that in the thinking area. Okay, so we have x equals 2 plus or minus the square root of negative 36, which simplifies to 6i. And then that's solved over 2. So it looks like we're going to have a non-real solution. So when that's the case, don't forget to put your answer in standard form for a non-real number, a plus bi. So let's go ahead and split it, separate the real part from the pure imaginary part, and then reduce if need be. So the first term that we see is 2. What's going on with the 2? Fraction bar. We're dividing it by the denominator of 2. Then we're going to add or subtract. What are we going to add or subtract? The second term, which is the pure imaginary part, fraction bar divided by 2. Alright, we separated the real part from the pure imaginary part, so we're on track to definitely earning our full credit. Quotient of 2 in itself will give us 1, and then quotient of 6i and 2 will give us 3i. So I think we did it. Okay, cool. So the direction says use synthetic division to show that negative 1 is a 0 of the polynomial. We divided using synthetic division. We showed that it's a 0, and then we had to find the rest of the zeros algebraically. We found them. Okay, so the additional zeros are going to be 1 plus 3i, and then 1 minus 3i. Okay, don't forget that your answer should not be submitted with the plus or minus symbol, because that doesn't really highlight that this is a comma, by the way. It looks like an accent. Okay, your answer should be submitted without the plus or minus symbol, because if you put it like this, it doesn't highlight that we have two solutions. The books usually leave it with the plus or minus because they want to save money on ink. Who blames them? Okay guys, that's my time. Thanks.